Let's take a look at another example where we are doing a hypothesis test. So in a sample of 2,246 randomly selected adults in the United States, 1,864 of them said that texting while driving should be illegal. Use a hypothesis test with a 5% significance level to test the claim that more than 80% of adults believe texting while driving should be illegal. So hopefully you can see here that this is dealing with a population proportion. So we're looking at a p-value, and here p represents the percent of adults who believe texting and driving should be illegal. Okay? All right, so let me highlight the claim again. So we're going to test the claim that more than 80% of adults believe in that. So let's write this using symbolic form. So the claim is that P is greater than 80%, greater than 0.8. So notice that the original claim does not contain equality. So this means that this is going to be the alternative hypothesis. So let me just write down the first step for doing a hypothesis test, which is to write down your hypotheses, your null, and your alternative hypothesis. So here, P greater than 0.8 is the original claim. So again, keep track of which of the two hypotheses is the original claim. And so if that's not true, then P is either going to be less than 0.8 or equal to. So we take the statement that contains equality, and that becomes the null hypothesis. So the null hypothesis value is 0.8. Okay? All right, second step now is to write down all of our sample data. So what do we have to work with? So if we write down all of our sample data, N, or sample size, is 2,246. X, which is the number of adults who said that they believe texting and driving should be illegal, is 1,864. That gives us a sample proportion of 1864 divided by 2246, which is approximately, we take it out to 2 decimal places, 0.83. So our sample data shows that approximately 83%, so 0.83, about 83% of adults believe that texting and driving should be illegal. So clearly this value is different from the null value of 80%. In fact, it's greater. But the question is it significantly greater than 80%? So is 83% significantly greater? And the only way we'll know if it's significantly greater or not is we have to calculate our z-score for this sample statistic. So we need to get our test statistic, which is the z-score, to tell us how far away our p-hat value is from our p-null value, okay, our hypothesis, null hypothesis value. And then after we get our test statistic, then we can calculate the p-value, which is the probability of getting a test statistic that is at least as extreme as the one that we got, okay? So you can either use your calculator to calculate the test statistic and p-value, or you can use the formulas. And let's take a look at the formula, okay? So to get your test statistic, if you're using the formula, that's a z-score. So we would take our p-hat value, subtract the null hypothesis value, and then divide that whole thing by the square root of the null hypothesis value times 1 minus the null hypothesis value. Divide that by the square root of 2,246. And then if you're using your calculator, use parentheses. Okay, put that all into the calculator, take the square root of that denominator. And this gives us a z-score of 3.55. So if you want to visualize this problem, we're using the normal distribution here, which gives us probabilities for a sampling distribution of sample proportions. So our p-naught value of 0.8 is in the center with a z-score of 0. And don't forget, we're using a significance level of 5%, so our alpha is 0.05. And because our alternative hypothesis was that P is greater than 0.8, this is a right tail test. So because it's a right tail test, my critical value, so Z sub 0.05, that's your critical value, is 1.64. So 1.64 is this line here that separates Z scores that fall in this critical region. Okay, so that has an alpha area of 0.05. And our test statistic, I'll use green here, is 3.55. So I can mark that here, 3.55. That's our test statistic. And hopefully you can see that it does fall in the critical region, okay? So it falls in the critical region. So that is our test statistic for our p-hat value of 0.83. And so if you're using the critical value method, you would say since the test statistic, which is 3.55, falls in the critical region, we're going to reject the null hypothesis. Okay. If you're using the p-value method, now you'll want to find the probability of getting a z-score that is at least as extreme as the one that we got. So we're looking for the probability of getting a value higher than 3.55. So here you would use normal CDF. So on your calculator, if you're using normal CDF, you'll get a p-value of approximately 0.000197, which is a really small value. And visually, we can see that p-value by this green shaded area. So that's your p-value, which is 0.000197. Okay, so clearly you can see from the picture that the p-value, the green shaded region, is less than the critical region, which is the red shaded region. So we would make the same conclusion about the null hypothesis. So here you can say since the p-value is less than our significance level, meaning 0.0001927 is less than 0.05, we would come to the same conclusion, which is to reject the null hypothesis. Okay. So that's step 5, making a conclusion about the null hypothesis. And then the last step is to interpret your results. So here, because the original claim is the alternative hypothesis and we're rejecting the null hypothesis, we would say there is sufficient evidence, okay, to support the claim that more than 80% of adults in the United States believe that texting and driving should be illegal. Okay. In fact, our data shows that the percent is as high as 83%. Okay. All right. So in the next slide, I'll show you how to do this on your calculator. So on your calculator, you're going to choose that stat button and then tab over to tests. Choose option 5, 1 proportion t-test. And then again, if you are using the calculator method, this is what you would write down to show your work. So you would write down what your null hypothesis value is, your x value, your n value, your alternative hypothesis, okay? Press calculate, and then your calculator will give you your test statistic. So here our test statistic is 3.54, very close to what we got when we used the formula. And then your p-value. Guys, pay attention to how your calculator gives you your p-value. So notice that p-value is 1.96, but we know that a p-value is a probability. So probability is always some number between 0 and 1. So 1.96 cannot be the answer because that's already greater than 1. So if you look at the rest of the number, it's e-4. That's your calculator's way of writing this in scientific notation, which is 1.96 times 10 to the negative 4th power, which basically means take this decimal, move it over 4 places to the left, so 1, 2, 3, 4, and so that is really equivalent to 0.000196, which is a really small number, okay?